LWO1 WeatherNet. Liftoff conditions looking pretty good.
The STS is ready for launch.
Ignition. Liftoff.
Falcon 9 has cleared the tower.
Ten, 9, 8,
Side booster ignition.
6, 5, 4, 3, 2, 1.
Happy New Year, everyone, and good evening. It is Thursday, January 7th, and you're tuning in to SpaceX's first mission for 2021. On your screen is a live view of the Falcon 9 rocket awaiting its 8:28 p.m. Eastern Time launch from Cape Canaveral Space Force Station in Florida. My name is Michael Andrews, and I'm a supply chain supervisor here at SpaceX, and welcome to the TURKSAT 5A webcast for our customer Airbus. Today's payload is a fifth-generation broadcast communications satellite for the TURKSAT fleet, designed and developed by Airbus. With an expected lifespan of more than 30 years, this new communications satellite is designed to provide television broadcast services and improve broadband data networks across a large geographic area, including Turkey, Europe, the Middle East, North Africa, Central West Africa, South Africa, as well as the Mediterranean, Aegean, and Black Seas. Now, before we explore more about today's payload, let's first take a closer look at the Falcon 9 vehicle supporting today's mission. The Falcon 9 rocket you see on your screen is standing at about 229 feet or 70 meters tall. And the bottom two-thirds of that vehicle is what we call the first stage. Now, while this is the first launch of 2021, today's booster is taking flight for its fourth time. It previously supported the GPS-3 Service Vehicle 3 mission in July 2020, as well as two Starlink missions, one in September 2020 and one a month later in October 2020. Falcon 9's first stage is responsible for accelerating the vehicle all the way to the edge of space, after which it will separate from the second stage, carrying that TURKSAT 5A satellite. And once separation is complete, we will attempt to recover the first stage on our drone ship for the fourth time. That drone ship you can see on your screen, known as Just Read the Instructions, is currently holding position in the Atlantic Ocean a couple hundred miles off the coast of Florida. And if we stick that landing today, for those of you keeping score, it's going to be SpaceX's overall 71st successful booster recovery. Now, after the first and second stage separate, the second stage will ignite its single Merlin vacuum or MVAC engine to carry the TURKSAT 5A satellite to a geostationary orbit. And at the very top, above the second stage, at the top of the rocket, you see a nose cone-shaped object. We call this particular assembly the payload fairing. It's 17 feet in diameter, 43 feet tall. It's 5 meters diameter, 13 meters tall. And this fairing houses today's satellite. Now, to transport the satellite safely, the fairing is designed to protect the satellite from aerodynamic heating, loads, and any kind of atmospheric contamination during ascent. And once we get through the Earth's atmosphere and reach the vacuum of space, the payload will no longer need this protection. We're then going to jettison the fairing halves so we don't have to carry around that extra weight, and the second stage will continue with the satellite to its targeted drop-off orbit for deployment. Both fairing halves were used during today's mission. They've been flown for the second time each. One half previously flew on the July 2020 Anasis 2 mission, and the other previously flew on that June 2020 GPS-3 Service Vehicle 3 mission. And following the deployment of today's payload, we'll attempt to only catch one fairing half in the air with our recovery vessel, Miss Chief, while Miss Tree, the other vessel, will retrieve the other from the water, what we call a wet recovery. And the last piece of the mix here is that large gray structure next to Falcon 9. It's called the Transporter Erector. We call it the TE. The TE is used to roll out the Falcon 9 from the hangar to the launch pad, and it then raises the Falcon 9 to its vertical launch position. The TE also routes things like power, fluids, and communication to both the rocket and the satellite. Prior to the start of our webcast, the Falcon 9 team performed functional checkouts for today's satellite. At T-minus 38 minutes, the team conducted their electronic go, no-go poll, and they gave the okay to proceed into propellant load and launch. Now, to keep both stages of the vehicle cooled close to launch, the team at Cape Canaveral began loading propellant at T-minus 35 minutes. Since the second stage Merlin engine is very similar to those 9 first stage engines, they both use the same propellants. Our fuel is a refined form of kerosene, we call that RP1, and our oxidizer is super chilled liquid oxygen, which we call LOX. We chill that LOX to be as cold as we can get it, and it allows us to load more LOX in there because those oxygen molecules are super dense. Both of these factors give us better performance with the Merlin engines. This also helps us to avoid the need to continue topping it off, and it makes up for any losses due to boiling prior to liftoff. Now at this point, the second stage is fully loaded with RP1, and the first stage will complete RP loading around T-minus 6 minutes. Also at this time, liquid oxygen is loading onto both the first and second stages, and that'll continue to the last few minutes of the countdown. At T-minus 7 minutes, we begin our engine chill phase. The pre-valves between the first stage engine and the propellant tanks will open. That chills the engines. This is where we cool those turbo pumps in order to avoid thermal shocks when we start the pumps at just T-minus 2 seconds, and it helps us light the Merlin engines. Also, we're loading helium into storage vessels on the first and second stages. During flight, we pass this cold helium through heat exchangers on our Merlin engines. The heat of the gas generator exhaust warms this cold helium and expands it. This expanded helium gas is used to fill the empty volume in our fuel tanks created by the engine pumps pulling propellant out of the first stage. Think of it like your car. We use gravity on a car to keep all the fuel near the bottom of the tank. Here in space, we need helium to push all that fuel towards our turbo pumps. Now, let's take a moment to learn a bit more about our payload today. Weighing in at approximately 3.5 tons, the TURKSAT 5A satellite provides roughly 10 kilowatts of power. By way of its high reliability and design, this 5th generation satellite will serve as the fleet's first satellite to operate under an electric propulsion system. And as I mentioned earlier, the TURKSAT 5A communications satellite was designed by our customer Airbus to provide television services and improve broadband data networks to service areas covering Turkey, Europe, the Middle East, North, Central, West, and South Africa, as well as the Mediterranean, Aegean, and Black Seas. The satellite is scheduled to become fully operational sometime in the second quarter of this year. Now let's take a moment to learn more about what makes this communications satellite so unique.
Standing by to launch command. T-minus 4 minutes. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
TURKSAT. Past, present, and future exist at the same moment. They are all building new experiences that inspire great ideas and breakthroughs in the blink of an eye. In the pursuit of innovative technologies, TURKSAT, one of the world's leading satellite operators, is now stronger in space with its new satellite fleet. TURKSAT 3A communication satellite at the 42° east location offers both satellite telecommunication and direct TV broadcasting services via Europe, Turkey, and Central Asia. TURKSAT 4A provides broadcasting services within a wide area covering Turkey, Africa, Europe, the Middle East, and Asia on KU band. TURKSAT 4B, a multi-band satellite, ensures high flexibility of switchability and connectivity among different service areas and provides services over a wide geographic region between west of China and east of England, spanning Turkey as well as Europe, Central Asia, the Middle East, and Africa on both KU band and KA band. Thanks to Airbus state-of-the-art technology, the most powerful satellite of the TURKSAT fleet, TURKSAT 5A, upon being operational with 10 kilowatts payload power, will be active across a wide area at the 31° east orbit covering Turkey, Europe, the Middle East, North Africa, Central
RP1
West
load is
Africa,
complete.
South Africa, as well as the Mediterranean and the Aegean Sea and the Black Sea. With its satellite fleet, TURKSAT focuses on rising values and technologies in satellite communication. TURKSAT is an alliance of values that opens doors to the world and inspires communication, with its reliable and expert staff investing in the knowledge of the future. We are in an age where information is instantly shared. Our expectations are rapidly changing. Technology is leading us to new experiences. We proudly proceed on a path illuminated by the information that makes our lives meaningful in the age of communication. While new experiences inspire great ideas, TURKSAT of the future invites you to be a part of this moment. TURKSAT, Space Age in Communications.
Mission Control, we have liftoff.
We're just about 4.5 minutes from liftoff. Shortly, the transporter erector is going to retract to its pre-launch position. We may see in a few seconds here the arms cradling right under those fairings. Watch those open up. What's going to happen is that TE is going to retract about 2 degrees from the rocket from vertical. And you can see right now those arms are opening up just slightly. In a few seconds, you'll see those arms back off as the TE retracts. And it's just, those 2 degrees is just a little bit of movement, but it's enough to clear the rocket to allow it to leave the pad. At liftoff, it's going to move to a position 45 degrees from the rocket. And you can see it's starting to retract a little slowly there. First stage fuel loading is complete, and we're currently awaiting for the first stage liquid oxygen loading to complete. And shortly after that, at about T-minus 2 minutes, the second stage's locks will also complete. One final big milestone before liftoff. You're going to hear the announcement that Falcon 9 is in startup mode. This announcement means that the rocket's own internal computers are now controlling the launch countdown on the Falcon 9. Once the engines are confirmed to be at full power, the flight computer, which is located on the second stage, will command the ground hold downs to release the rocket right at T-minus 0. The satellite team continues to monitor the status and health of the TURKSAT 5A payload located inside the fairing on the top of the second stage. All systems are go on the satellite. In terms of range and weather, currently everything appears to be on track for an on-time launch. The range is green. We've been monitoring weather. The only primary concern we have is the cumulus cloud, thick cloud rule. But right now, conditions are looking favorable. The percent of violation is 30%. That means there's only a 30% chance of us postponing liftoff. So things are looking good. If for some reason we have a call on today's launch, we may be able to begin again within this launch window tonight. But we do have a similar 4-hour backup opportunity scheduled for tomorrow evening around the same time. But for now, all systems continue to be go for an on-time liftoff at 9:15 p.m. Eastern Time. At this time, the LOX loading is complete. It just finished on the second stage, and that is the last milestone for propellant loading prior to liftoff. You're going to start seeing a buildup of white clouds emanating from the Falcon 9. That's perfectly normal. That's that excess liquid oxygen boiling when it's exposed to the ambient temperature of the air around the Falcon 9 fuselage.
Ground gas closeouts.
The first and second stage are beginning to pressurize for launch, and we're about 15 seconds away from that startup mode call out.
Flight computer has entered startup.
We have confirmation of start out. We're just waiting for launch director's go for launch call out.
TURKSAT 5A, Falcon 9, LD is go for launch.
And you've heard it, we're 30 seconds away. All systems are go for an on-time launch of Falcon 9 with the TURKSAT 5A satellite, our first launch for this year.
30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And liftoff.
Stage 1 chamber pressures are nominal.
The vehicle is pitching downrange.
We're now 30 seconds into flight on the Falcon 9. All engines are running at full power. We are preparing to enter through our first major milestone after liftoff, max Q. It's going to occur at T plus 1 minute 12 seconds. We're going to throttle those engines down. We've confirmed nominal status from the avionics team. Next, max Q. That's when the vehicle experiences the greatest amount of dynamic pressure. We throttle those engines down, and afterwards we throttle them back up to keep dynamic pressures below a certain level.
Falcon 9 is supersonic. Max Q.
We've successfully crossed the max Q threshold. Everything is looking good with the first stage's trajectory. Next, we're going to start our MVAC chill. This is going to help us prepare for the next 3 major events. They occur one after another. The first one, those 9 Merlin 1D engines are going to cut off. That's known as MECO, or main engine cutoff. Right after that, the first and second stage will separate, and then the Merlin vacuum engine on the second stage will turn on. That's known as SES-1. About 15 seconds away from throttling down those Merlin 1D engines, you'll start to see that visual change and that plume you see on the screen.
Main engine cutoff.
Stage separation confirmed.
All right, all good news here. We had successful main engine cutoff, stage separation, and second engine start 1. Our next milestone is fairing deployment. Those 2 fairing halves on the top of the second stage are no longer needed, and we'll jettison them to help expose the TURKSAT 5A satellite to space and attempt to recover those later on.
Second stage is on a nominal trajectory. Fairing separation confirmed.
And you saw there, we just jettisoned our 2 fairing halves. It's our first good view of TURKSAT 5A. It's now exposed to space, and those 2 fairing halves are heading back down to sea level. For those of you just joining, we're 4 minutes into flight on today's mission of carrying the TURKSAT 5A satellite to its intended orbit on the Falcon 9. We're currently in the first of 2 planned MVAC burns. That's what you see on your screen currently. Not pictured here currently, but that's after stage separation. The first stage, we're attempting to recover it. Its velocity at separation was about 2,200 meters per second, or 5,000 miles per hour. Once the separation occurs, the first stage is still moving at such a high velocity, it continues to raise its altitude as it approaches its apogee, and then it will coast down a couple minutes before it starts its return back to Earth. Up next, what you'll hopefully see is the first stage's entry burn. This is the first major milestone for first stage recovery. For entry burn, we're going to relight the center of those 9 Merlin engines. It's actually engine number 9. And partway through this transition, we then ignite 2 more engines, engine 1 and engine 5, which means we have 3 total M1D engines helping slow down the vehicle as it passes into the Earth's increasingly thickening atmosphere. That burn will last about 30 seconds, and we're just about a minute away from that. And also not pictured here, those 2 fairing halves are making their way down. It'll take a lot longer than it will for the first stage, but we will attempt to recover those later on in the evening.
Expected loss of signal, Cape.
First stage is now less than 100 kilometers above sea level, continuing to make its way down. Just 10 seconds away from entry burn. As you watch this here, watch that exhaust expand as it goes from 1 engine to 3 engines. It'll sort of elongate.
Stage 1 entry burn startup.
Entry burn has begun. All 3 engines are running currently.
Stage 1 entry burn shut down.
You heard it, you saw it. Entry burn has shut down. Next, a couple milestones happening back to back. On the second stage on your screen, we're going to turn off that MVAC engine. It's known as SECO 1, or second engine cutoff 1. And right after that milestone, we're going to start our final first stage burn, the landing burn, hopefully culminating with a 4th landing of this particular first stage. Going back to SECO, we shut down the MVAC, and after that period, we actually allow the second stage to coast. This event preserves the fuel until we need it for that final burn, second engine start number 2, and it takes us to our targeted orbit for today's satellite deploy. We're about 30 seconds away from SECO 1, and after that, only about 30 more seconds until we hopefully have a nice view of the first stage touching down on our Just Read the Instructions autonomous drone ship.
Stage 2 FTS is saved.
Stage 1 landing burn startup.
Our landing burn has started. Our second engine is also cut off, as you can see. We're just awaiting confirmation of good orbital insertion. And back on sea level, you can see here the drone ship. We have confirmation of good orbit on the second stage, and looks like we have a good landing on the drone ship as well. This is SpaceX's 71st successful first stage recovery. This particular booster's 4th successful recovery, getting ready for its 5th flight in the future. That's our secondary mission, vehicle reusability, but our primary mission's not yet complete. The second stage vehicle has now entered its first coast phase and will last about 18 minutes. After that, we're going to light that MVAC engine for a second time shortly after at about T plus 26 minutes 51 seconds. For those of you interested in keeping an eye on where that second stage is throughout the coast phase, you can follow along with our animation for the next 18 minutes. Otherwise, we'll see you back here at T plus 25 minutes.
Expected loss of signal, Bermuda.
Welcome back to the webcast, the Falcon 9 mission carrying the TURKSAT 5A satellite designed and developed by Airbus. Let's recap what's happened so far this evening. We had a smooth liftoff at 9:15 p.m. Eastern Time. 2.5 minutes later, our first and second stages successfully separated. The first stage made its fourth flight and its fourth landing on our drone ship. Just read the instructions. The second stage completed its first burn and successfully inserted today's payload and second stage into their planned parking orbit where they're currently at now. Now we're coming up on the second burn of that upper stage engine in a little more than 60 seconds. Currently, the flight computer is commanding the settling thrusters to turn on and off, and it releases nitrogen gas that helps lightly push the stage and allows propellant to stay at the bottom of the tank above the engine. One thing to mention here is that the ground station over Gabon at the minute is down, so we won't be able to provide any visual views or have any confirmation of when exactly that second engine start occurs and when it ends. We'll tell you when those are expected to occur, and after our next coast phase, we'll come back and confirm how those events went and if we're in a nominal orbit. And currently, we do expect for that second engine start, SES-2, to occur. At this point, the nominal burn duration is 70 seconds. Currently, that second stage is traveling almost 8,000 meters per second. This burn is going to add another 2,000 meters per second to the Falcon 9 speed before it shuts down for a second time. This shutdown event, called SECO-2, which is hopefully 45 seconds from now, that's then for second engine cutoff number 2. This burn places the TURKSAT 5A satellite into the required orbit prior to separating it from Falcon 9. And at this point, we expect for second engine cutoff 2 to occur. Like I mentioned before, the ground station over Gabon in Central Africa is down at the moment. However, the Falcon 9 second stage is an incredibly reliable vehicle, and we trust those events are occurring at those nominal callouts. But we will come back after our next coast phase and have some information when we're over the next ground station and give you more information. And as a reminder, the TURKSAT 5A satellite is still attached to that second stage. The stage is now going to start a slow spin, kind of like a football, that helps stabilize the satellite when it's released. This transition is going to take 5 more minutes, and satellite separation is expected to occur at T plus 33 minutes and 4 seconds. Now, while we wait for the satellite to get closer to its final destination, we'll pause commentary during this coasting phase, but we'll come back just before Stage 2 separation takes place at T plus 32 minutes.
Acquisition of signal, HPK.
Nominal deploy orbit insertion.
Welcome back again to our launch coverage of the TURKSAT 5A mission. One quick note, we're actually not spinning the second stage of this mission, but unfortunately I can confirm we had a good orbit after our second engine start, which is great news. If you're just joining us, we have one more major milestone coming up in about 10 seconds. That's the deployment of the TURKSAT 5A satellite.
Payload deploy confirms.
And you can see it. We have confirmation of successful payload separation of the TURKSAT 5A satellite, and that will now bring today's webcast coverage to a close. Before we go, we really want to thank Airbus, our customer, for entrusting us with the TURKSAT 5A satellite. This mission marked the 4th launch and landing for this Falcon 9 booster. It was also SpaceX's 71st successful booster landing, as well as SpaceX's 50th time for flying a reflown booster. Also, it's our first launch for 2021. To the range and the FAA, we appreciate having your support and acceptance for today's mission. And to all of our viewers, you, as always, thank you for tuning in, and have a great evening.